So last section we looked about if lines are parallel, that there were some special relationships between the special pairs of angles. Today we're going to look at now how could I say make sure the lines are parallel? So kind of the opposite of what we learned on the last goal in the last section. So we're now going to say, look at those angle pairs, recognize them. So hopefully by now that you have a pretty good understanding of those angle pairs, and then knowing what we know about those angle pairs, prove the lines are parallel. So we start with the converse. Remember, converse is just flipping the if then. So before we had if lines are parallel and they're cut by a transversal, then the corresponding angles are congruent. Now we're flipping it, so we're saying if the lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. So here's our condition. Have to have two lines cut by a transversal. So a transversal, a line that transverses across the two, and I need corresponding angles that are congruent. When that happens, then the lines are parallel. So if I look at that, it's just the opposite of what we said before. So what we would say then, if angle 1 is congruent to angle 3, because those are corresponding, then I know A is congruent or parallel. Line A, not capital A, that's a point. Line A is parallel to line B. And again, this is my parallel sign, so we're looking at those. And just some things, because we can get many lines, like say I have more lines here. When we're looking at what lines then would be parallel, we look at, so this line is the transversal, because that's the line that 1 and 3 are both on. And so then the lines that are parallel, based on those being congruent, would be the lines that they're each individually on, so A and B. So when we're looking at these and we get a page full of lines here, or a bunch of lines, that's where we're looking at. The one that they're on, connected, both on, is the transversal. The one that they each individually touch is the lines that are parallel. So that's going to be pretty key. So then that brings us to the same thing as the converse of all our others. So we said alternate angles are congruent if we have a parallel lines. Now we're saying if the alternate exterior angles are congruent, then the lines are parallel. If the consecutive interior angles are supplementary, then the lines are parallel. If the alternate interior angles are congruent, then the lines are parallel. And then if the in a plane, if two lines are perpendicular to the same line, then they have to be in parallel. So just kind of flipping all of those theorems. And what we say when I can put the inverse and the converse together and they're both true, then I could say sometimes then it'll say if and only if. And that means that you can write this both ways, and it'll be true. So again, what we're looking at is given 1 is congruent to 3. So 1 is congruent to 3. Those are corresponding angles. So that's the postulate that I would look at, is identifying them. So corresponding. So state the postulate or angle, and I'm not going to write the whole postulate out. Basically what I'm wanting here is what type of angles are those. So those are corresponding angles. One's interior, one's exterior. So then since these are congruent, then that means a couple lines are parallel, and what lines they would be the one that they're each individually on. So they're both on this one, so that's my transversal. So 1 is on A and 3 is on B, so that would make A parallel to B. So here we have angle 1 is 103 and angle 4 is 100. So look at what type of angles those are. Those are alternate interiors, so we're kind of forgetting about this one. But notice they're not equal, so that means they're not congruent. So there's A is not parallel to C. So I can put that line through it there. Or I could say that there's no lines parallel on that because these are not congruent. So we've got 1 and 5. So I look at those. Again, I'm not looking at this line at all because it's not touching, those angles aren't touching that line at all. So I can kind of pretend it's not there. And so I look at what type of angles those are. Those are corresponding. And since they're both congruent, as I'm told here, then that would mean that P is my transversal, the one connecting them. And so the parallel lines would be L and N. So L is parallel to N because those are corresponding. So then we can do the opposite, like we can make these parallel. Same thing if I was like trying to build something where I have, you know, my sections and I want to make sure these lines are parallel or the same distance apart. I could just keep turning this until these angles are congruent, or my alternate exterior angles or alternate interior angles are congruent. So what we're looking at is then going opposite. We want PQ to be parallel to MN. So I need to find what this angle needs to be and how it relates to this one. So looking at those are alternate exterior, and if these lines are parallel, then these would have to be congruent, and I want them to be parallel. So if I put them congruent to each other and solve for x, subtract 7x over 4x minus 25 equals 35, and add 25, 4x equals 60, and then divide by 4, x equals 15. So what x equals, that was what x would have to be equal for these to be equal, and which would make these parallel. But we want to know what this angle has to equal, ZYN. So to figure out that angle ZYN would need to equal 7 times 15 plus 35. So sorry, 7 times 15 is 105 plus 35 is 140. That's how 7YN would have to equal. That's not right. I don't think I did that right. No, that's right. All right. So make sure you're really watching that. But again, it's kind of the same as before. Now we're just making them parallel by making those lines either equal or supplementary. So then looking at these two, we're finding x. So really watch that. So I look at these two. These are alternate interior angles. And in order for this line to be parallel to this line, we need to have those equal. So 9x minus 21 needs to equal 7x minus 3. Subtract 7x. 2x minus 21 needs to equal negative 3. Add 21. 2x needs to equal 18. And then divide by 2. X would have to equal 9. And we can see that the same thing, like again, if I was constructing this and I want to make sure that these are parallel, I could measure these angles, make sure that these are all equal, which would make these lines parallel to each other, and keep going along there. So I can measuring the corresponding angles or alternate interior angles, making sure that those are equal where they need to be equal, or supplementary where they need to be supplementary. Right. If you have any questions, let me know.